Okay, hi guys. So in this lecture we'll be seeing limiting agent in detail. Limiting agent. So limiting agent is a reactant which is present in limited amount, so which is lesser than the stoichiometric amount, is called limiting reagent or limiting agent. Okay, so reactant present in limited amount which is less than the stoichiometric amount, is called limiting agent. Okay, and limiting agent actually is consumed first in the reaction. Limiting agent is consumed first in the reaction. Limiting agent determines amount of product formed. And product should be formed on the basis of limiting agent. That is also implicit. Okay, so let's see some examples. So suppose we have 2a plus 3b gives 4c. Okay, so suppose we have 2.5 moles of a and 5 moles of b. I'm not writing moles again and again. So how many moles of c would be present? So let's say if we have x moles of so before that, let me write that 2 moles of A would combine with 3 moles of B. Okay, so now y moles of B would combine with 2 by 3 y moles of A. Okay, so you can say that 10 moles of B would actually combine with 20 by 3 or 6.66 moles of A. Okay, but how many moles of, or rather we can say that 5 moles, not 10 moles. It is 5 moles given in the reaction, so 5 moles will be combining with 10 by 3 or 3.33 moles of A. Okay, but moles available for A are just 2.5. okay, so A would be limiting reagent. Okay, so this would be limiting agent or reagent, whatever you may like to call it. So now this reaction would be driving the number of moles formed of the product, which is C in this case. So initially we had 2.5 moles of A, 5 moles of B and 0 moles of C. Now finally we would have all A would be exhausted, and how many moles of B would be produced or left, or rather how many moles would be consumed and how many would be left over. So we have seen that 2 moles of A will combine with 3 moles of B. So 1 mole of from here, 1 mole of A will combine with 1.5 mole of B. Similarly, 2.5 mole of A will combine with 1.5 into 2.5 mole of B. So you can calculate how many is this term. So just subtract it from 5 and you will get moles of B present after the reaction, and how many moles of C would be present or found in the reaction? 5. Why? It is double the moles of A. So 2.5 moles of A were used, so 5 moles would be produced. Okay. So next, let's discuss the simple method to actually find what is the limiting agent in any reaction. So method to find limiting agent. Okay. So you just have to see that you just have to compare moles of A, which is given in the mixture, divided by its stoichiometric coefficient, and moles of B divided by stoichiometric coefficient. So whichever is lesser would be the limiting reagent. Okay, so in the previous case this ratio was lesser, hence A was the limiting agent. Let's see another example. So in this example we have 3 moles of X, or rather stoichiometric coefficient of X is 3, plus 4 of Y gives 5 of Z. Okay, so let's say it is present in 18 moles, it is present in 21 moles. Okay, so what would be the limiting reagent? So let's calculate the ratio. So moles of X divided by stoichiometric coefficient of X, and moles of Y divided by stoichiometric coefficient of Y. So obviously this is larger, hence Y would be the limiting agent or limiting reagent. It would drive the number of moles form of Z. Okay, so you can calculate how many moles of Z would be formed after the reaction gets over. So you can just write that reactant which has lesser mole per stoichiometric coefficient ratio will be limiting reagent. Okay, and steps to find limiting agent would be: first you have to balance the given reaction in order to find the stoichiometric coefficient. Balance the reaction, then we have to calculate moles of every reactant, or just directly I'm writing that divide the moles of reactants with their respective stoichiometric coefficient. Okay, now let's take another example wherein we have 4 moles of A plus 3 moles of B plus 2 moles of C gives 5 moles of D plus 3 moles of E. So in this case, let's suppose moles you have been given, that is 5, 7 and 6. So to find LR, you have to divide moles of each individual components or reactants with the stoichiometric coefficients. So in this case, it is, you can calculate that 5 by 4 is the least value of the ratio, hence A is the limiting agent. Okay, so let's take another interesting problem wherein you have been given an impure sample. Okay, it is the real life scenario, or rather a real world scenario. So you have impure sample of X contains X plus impurity. Okay, so impurity is impurity of the mixture won't be reactant in the reaction. Okay, so let's say you have 10 gram sample of MgCO3 which contains 75% MgCO3, which means the rest 25% is impurity. Okay, so this implies that weight of MgCO3 would be 7.5 grams. Okay, and moles of MgCO3 present in the mixture would be 7.5 divided by the molar mass of MgCO3, which is 84. Okay, so now MgCO3, or rather the mixture, is heated so as to get MgO plus CO2. So if we have to calculate the weight of CO2 present or CO2 formed, we have to go by number of moles of MgCO3. So if it has X number of moles, both the products would have X number of moles, and that X is 7.5 over 84 into 44 grams. This would be the weight of CO2 produced. Okay, and let's define what is a residue. Residue is the substances left in the bottom of the vessel after the reaction. Okay, so residue is substances left in the bottom of the vessel after reaction. Okay, so in this case, what would be the residue? Residue in this case would be MgO, which formed a PBT plus impurity. Okay, so we can calculate the mass of residue also after the reaction gets over. Okay, because CO2 is a gas that would be leaving the reaction mixture, so MgO plus impurity, for the calculating the mass of MgO, you can calculate by a number of moles into the molar mass of MgO, plus impurity was 2.5 grams. Okay, so from here you can calculate the weight of residue formed in the reaction. Okay, so this brings us to the end of this lecture. In the next lecture, we'll be seeing more examples on the same concept, and we'll be seeing percentage yield. Okay, so till then, good luck and goodbye.